Welcome back. In this video, we are going to solve another one of the important programming challenge of Hackerrank, and name of that programming challenge is binary search tree lowest common ancestor. In this programming challenge, we will get one input as a tree and we will get two int values v1 and v2, and we have to find out the lowest common ancestor of that tree. Okay, let's understand this problem with the help of an example. And our int values are, and our v1 v2 values are, v1 is 1 and v2 is 7. Now if this is the v1 and 7 is the v2, then tell me what is our lowest common ancestor. The lowest common ancestor of 1 and 7, I can see this one is the 4. So our returning point of the node will be start from that 4. Okay, that will be our output. So we understood the problem. Now let's see the constraint of this problem. Number of nodes and node data will be between 1 to 25. Okay, and v1 v2 values are between 1 to 25, and the most important thing is v1 should not be equal to v2. So this is our constraints. So what are the things that we covered here? We understood the problem with the help of an example, and we also saw the constraint of this problem. Now what is the next thing that we are going to cover? We are going to solve this problem with the help of a Java programming language. Okay, so to solve this problem, what we are going to do, we are going to take previous example as our input only. Now, before we start solving the problem, we need to understand one important concept. That is that all the tree that we will get in this programming challenge will be in the binary tree. What does that mean? Whenever I say binary tree, that means whenever we have a one root node of a tree, for example, let's say 2 is the root node, then the left hand side of a tree will be smaller and the right hand side of a root node will be greater. For example, let's say 4 is our root, correct? If 4 is our root, then 2, 1, 3 is smaller, that will be left hand side, and in the right hand side 4, you can 7 and 6. 7 and 6 are greater than 4. Similarly, if 2 is our root, if we will consider, then leaf nodes are 1 and 3. 1 is in the left direction, so it is smaller. 3 is in the right direction, that will be, so that is greater than the root. Similarly with 7 has one leaf node 6, which is indicated in the right direction, which is indicated in the left direction, so that's why it is smaller. This type of a tree we will call it as binary tree. So why we are covering this binary tree concept in this problem? The reason, because we are going to use this binary tree concept to solve our problem. Okay, now to solve our problem, what we are going to do, we are going to write two if condition in our Eclipse code. Let's go to our Eclipse code. We are going to write our logic inside this LCA. Here you can see that we are getting 3 arguments here: root, which will provide us the input of reference of node 2, and 2 int values v1 and v2. So acquire our result, we need to provide 2 if values. So let's provide. Now the condition of first if root will be root dot data greater than v1 and root dot data greater than v2. Okay, and the second will be root dot data less than v1 and root dot data less than v2. Let's understand this concept with the help of an our input that we have given here. So if 4 is the starting value and 4 we will consider as root, so whenever I have written, whatever I have written in the if conditions, the first if condition says if 4 greater than 1 and 4 greater than 7. So you can see that 4 is greater than 1. Yes, true. 4 is greater than 7. No. So true and false. So this if condition will be false. It will not go inside if condition. Now what about the next one? Next one says root, that will be 4 less than 1 and 4 less than 7. First one, 4 is less than 1. Condition is false. 4 is less than 7. Condition true. So here false true, it will become false. So it will not go inside in any of the if condition. So if it will not go any of the if condition, the top root value will be our result. So what is the top root value? 4. So we are going to return this value. So how we came through that result? So if our v1, v2 values comes under between left and right, that means the joining node will be our required result. So what is the joining node? Joining node is 4 because 1 is there and 7 is there. If 1 and 7 we will calculate, we will not even go into that. It is not even true in the greater. It's not even true in the smaller. So that means this will be our answer. Okay. So we understood this part. What we will do, we will take one more example to understand this concept in a much more deeper way. The example tree we will take as and our v1, v2 values are v1 is 9 and v2 is 12. This is our v1 and this is our v2. Okay. Now next we will follow the same two if condition that we have written. So what is the first one? First one is the 8 root. So if 8 is the root, so 8 is greater than 9 and 8 is greater than 12. So 8 is greater than 9. No, condition is false. And 8 is greater than 12. Condition is true. So this is the false condition. So it will not go inside in the first if loop. What will be the second if loop? So second if loop says if 8 is less than 9 and 8 is less than 12. So 8 is less than 9, condition is true, and 8 is less than 12. So what does that mean? That means our v1 and v2 exist in the right hand side direction. That is not because both are greater. If both are greater, that means both are lies, v1 and v2 lies in the right hand side. If v1 and v2 lies in the right side direction, that also means that our lowest common ancestor node also will lies in the right hand side direction. So what we are going to change the root from root dot right. So what it will do, it will change the root to the right direction, and through that again we can traverse. So for that, what we will do, we are going to write here LCA root dot right v1 v2. Okay, to return here. Go back to our editor here again, and here. So what it will do, when it became the if condition true, then it will go inside the if condition and it will change the root dot right. So what is the root dot right? Root dot right is the 11. So now root change again. Now let's compare with the first if. So what we did in that, we called the again recursion we call again this method. So it will go into the first loop. What is the first one? 11 is greater than 9 and 11 is greater than 12. So 11 is greater than 9. Condition true. 11 is greater than 12. No, it's not. So it is false. It will not go inside this if condition. Now the next one. What is the next? Next one is 11 less than 9 and 11 is less than 12. So 11 is less than 9? No, condition false. In this one 11 is less than 12, condition true. So that means 11 and 12, 9 and 12, it will not go inside in the right side direction and not even go inside the left side direction. That means whatever the current node is there, it is our lowest common ancestor. That one is 11. So this one is, we are going to return to that answer. Okay. So for that purpose only I have written here LCA, because after that root it is going to call it here. So again it will call here and it is going to return. Okay. Now what if our node V1 V2 values are, instead of 9 and 12, it should be 5 and 7 direction, 5 and 7, then it should not go into the right hand side direction, then it should go to the left hand direction. And which scenario it is going to occur? Then in that time we are going to compare if 8 greater than 5 and 8 greater than 7. So 8 is greater than 5, yes, and 8 is greater than 7. Okay, so root is bigger, so that means those two are smaller. If those two are smaller, then it will go into the left hand direction. So what we are going to do? Yes, we are again going to change the value from root to root dot left. So we will just copy this one and we are going to call root dot left. That's it. Okay, and according to that it will travel, and whenever it will find the required value, it will return back from the given position. If it is the 6, it will return back from the given 6 and we will get our required node pointer root. Same thing will happen from this one. It will call here, so this is a recursion, right? So one condition it will return, so again it will go back our position and it will return the required from the 11 node pointer to the root. Okay, so this is the logic that we have written to get our result. Now what we will do next? We will try to execute the code and see if this one provides the correct output or not. Let's try this one. The answer of this one we already know, that one is 4, but we need to see that our code is working fine or not. Okay, we are getting our output. Now the next. This time 9 and 12 is given and we know that 9 and 12 V1 V2 values are there, then answer should be 11. Answer came 11. Okay, now what we will do? We will try to execute one more time, and this time we will change the value from 9 and 12 to 5 and 7, and here 5 and 7 the LCA is 6. Let's see if it provides 6 or not. It provided the 6. That means the logic that we have written here is correct. So what we will do next? We will just copy the code here, paste it to Hackerrank console, and let's run the code. All the 3 test cases got successful. Now let's submit the code. Now here we can see that all the test cases got successful. So the logic that we have written here is completely correct. Okay, and with that, this is the end of the video, and again in the next video we are going to talk about another one of the important programming challenge of Hackerrank, and all the practice code that we have provided here will provide the GitHub. I will upload it in the GitHub, and GitHub link I will give in the description section. So stay tuned for the upcoming video of next Hackerrank problem challenge. Okay, thank you.